future technologies will require rapid advancement in chip development and a streamlining of manufacturing processes. That's the topic for this panel, Regional Strategies for Semiconductors, moderated by Dean Ramos, principal at Arca Capital. Over to you.
Thank you. I'd like to introduce the two gentlemen. To my immediate left is Raimons Lapinš, Deputy State Secretary, Ministry of Economics, Republic of Latvia. To his left is Ben Sokolowski, Managing Director, VP of Government Relations at Qualcomm. And we don't have much time, so we're going to dive right into it, if that's okay. First question for you, Raimons. Regional semiconductor development has become a prominent component of industrial policies around the world in the last several years, especially since the pandemic. The reasons to develop regional chip capabilities vary by region, as do the way these efforts manifest themselves. In short, the strategies vary by region and country in terms of capital commitment and resource focus. Can you describe for us the Latvian strategy and its goals, objectives, and what resources will determine its specific success?
Yes, I can do it, I think. Yesterday we signed even a memorandum of understanding with industry. Actually, before we started with chip semiconductor industry, we did short strategic assessment. So we defined several possible goals. Like, for example, we would like to have chip in facilities there in Latvia, for example, whether we are part of or we are part of value chain in chip industry, or we are just designing chip designs and that's it. The most important thing was the first steps is the same. And it's nothing new. So we are building on existing industrial capacities and research capacities what we have there in nanotechnology side, on side of chip development and electronics development and ICT skills. And the first steps is completely similar for any of these choices. So it's human capital and research based from government side where we have to invest. Clearly, as a government, we do understand that, and there is no strategic option to invest 7 billion euros in Latvia for next year to start to develop chips and produce them, because actually we are not interested. Let's larger countries, larger companies where do understand where to invest, do this thing. Let's do for us what we are strong at. And we are strong at niche parts. So human capital and research will define whether and what will be our strategic success or not success in this one.
Okay. So as a follow-up, one of the traditional criticisms of top-down industrial policies has been the lack of market signal incorporated into resource allocation decisions when directing this sort of long-term plan and planning. This has been and may well be in the case of semiconductors a factor that will determine relative success of these efforts around the world, because Europe and Latvia specifically are not alone in sort of going on this path right now. Do you agree with this statement?
Yeah,
first
completely.
of all? And if so, how does Latvia propose to incorporate the market mechanism and the market signaling mechanism in the allocation of resources and capital and the composition of strategy for semiconductor development?
Yes, and this is one of the problems with always with governments, that they are good at plans, bad at strategies. They are good at planning everything like nobody is doing anything, so it's like only on the planet. So this is in semiconductors, we will at least try to avoid this. That's why it was so important that industry, like 7, 8 largest players in Latvian economy in electronics and ICT, defines what they see as first steps to be done, that they can actually grow their capacities. We are developing like a roadmap for the first 1.5 year, what have to be done, but strategic goals, we are using opportunity everywhere, and including this conference and most probably next year, to recheck it with like Qualcomm, who do see better than governments what's actually is moving ahead, where is markets, what is missing parts in markets, and so on. So this ongoing recheck of what we are thinking and where we're moving with people who are just smarter and do understand this specific field better. This is the route. We have done it in several fields, starting from forestry, ending at biotech. We do this, that we are rechecking with industry itself where they are seeing, where it's moving, and how to adjust goals. And so if yesterday we signed that we are planning in 15 years to reach the positions that we are ready to build chip manufacturing, doesn't mean that by moving forward in these actions, we don't change the goal. We can do it if there is sense and industry says that, guys, there is market, part of the market which is much more interesting for us to cooperate on these issues.
Okay. I'm not going to let you off the hook. So Qualcomm is a global leader in fabless design innovation, obviously, and one of the largest customers for leading foundries worldwide. Qualcomm's view of emerging trends, long-term technology directions, and the relative strengths and weaknesses of participants in the global semiconductor ecosystem is unparalleled. Actually, I think that's probably a true statement because your vision into the whole system is pretty complete. You, as Managing Director for Government Relations, can view government's efforts in this sector through a unique lens because of that. What is Qualcomm's view of the risks and opportunities for the industry of the renewed and to some degree competitive global trend toward regional chip technology development?
Right. Thank you, Dean. As you said, Qualcomm is a leading chipset design company, does not produce the chips. We don't manufacture the chips ourselves, but for this, we work together with the leading foundries globally. And in this regard, obviously, we have a very strong and vital interest in a diversified semiconductor supply chain and also diversified production capacities globally. And in this regard, we clearly support and appreciate both the European Chips Act as well as the US Chips Act, because the intention and the goal to localize production capacities from our point of view is really the right decision. So talking about opportunities and risks, clearly a risk for the industries, and not only for the semiconductor industry, but also for those industries that use the chipsets, which in the future will be pretty much every industry. The risk certainly would be not to do that. Right? Now talking about opportunities, I'm sure we're going to talk about this later, countries, also smaller countries, by identifying their sweet spots, their strength, can benefit from the only growing demand that we do forecast in semiconductor markets in the years to come. A risk that we currently observe is a strong focus, obviously, of investment into leading edge nodes, so the smallest node sizes, which on the one hand is good because there we see currently the biggest dependency also in North America and particularly also in Europe from Asian producers. But that should not lead, and that is currently what we observe for reduced investments into more mature node sizes, right? Which also for the foreseeable future will be very important also for industries which are key for Europe, automotive industry, for example, which will remain big customers for these mature node sizes. So in terms of risk, we clearly advocate for a well-diversified also investment also from governments and support schemes into all node sizes from leading edge into mature.
So you've sort of answered this next question a little bit, but given Qualcomm's vision into the long-term technology development, specifically related to its impact on the value chain in semiconductors, how do you see the critical capabilities of that value chain evolving, and could a city like Riga and a nation like Latvia successfully play a part in that future? So I'm going to put you a little bit on the spot since we're sitting right there.
No, of course, with pleasure. Right. So as I said, so the production capacities to allocate really chips and manufacturing is very capital intensive. It is risky, and it is not the only place to be for a country which will want to benefit from the growing demand, right? And therefore, I think both the Latvian government and the city of Riga in this regard has done many things right, and it's impressive if you come here to see actually what the country and the city has already done, right? Because I think first you need to identify where am I good at, what could be my strength, where do I want to be, where do I not want to be in the semiconductor supply chain. That could be, for example, in attracting and incentivizing certain parts, both hardware and software of the supply chain. But also it could be by setting the right regulatory environment to attract startups, to attract companies who would like to invest, right? So if you generate a regulatory environment that is supporting innovation, that is also attracting risky innovations, but that also provides the right skill set in terms of workforce, and that is currently something that Latvia has identified as a key critical component, rightly though, then I think you have already done many things right.
So this is a question for both of you, so you can both take a crack at it. Given this is a 5G conference, and 5G can be seen as, to me anyway, fundamentally more commercially driven set of use cases, as opposed to prior generations of the air interface development, which were more consumer oriented. Do you see this generating different regional opportunities or even city level opportunities and the requirements that governments and technology providers are going to need to consider and maybe could exploit commercially?
Yep. I think that, and by the way, this semiconductor strategy and where we are moving is actually born in 5G conference. It was just, I think that 3 years ago when we started to discuss. And capacities in Latvian case, yes, they're unique, and they're coming from 5G because there is several companies which are developing components for 5G infrastructure, and that's why I think that it's again, it's as you said, it's for small nation. It will not be general semiconductor production. It will be some specific components of competitive advantages where we have and they are in knowledge and in scientific, like in knowledge part, not in capital part, not in mass manufacturing. It's more in this knowledge. So yes, that's why I think that and yes, 5G, it's nice name. Actually, it's not anymore so about 5G. It's about broadband wireless communication, and yes, there's several developments. For example, not only anymore in electronics, there is optical routing too. Again, and these are all the components which are coming together and which are building this unique positioning what we will have there in Latvia. And I think that it applies for any of the countries. Like I can imagine that semiconductor capacities in Estonia and Lithuania will be a little bit different, keeping in mind that they have strengths in different parts of both science and technology.
Yeah, I would definitely echo that. So 5G definitely can become a competitive advantage for those countries and regions who do it right, because with the rapid digital transformation of many industries, with metaverse that we discussed yesterday, with autonomous driving towards the end of the decade, we will see only a growing demand in really superb digital connectivity infrastructure. Digital infrastructure, most of it mobile communication. So therefore we really see that a high-performing 5G network, also including innovative 5G technologies, for example, millimeter wave technologies, ultra-low latency, super high bandwidth, that these regions and these countries who put a strong focus on deploying the right network will gain and benefit from these competitive advantages.
And just and adding to this, completely right. And by just starting to use these technologies, it's giving next pressures for innovation, like everything related now when we start to talk about mobility and 5G, questions about computation on the edge and so on. So it's just using these technologies is pushing more in the territory, which is where there is really competitive advantage. So we are building user specific knowledge in this field.
Okay. We have a couple minutes left, and I'm going to use up all my questions before I let anybody else ask any. One for you, Ben. The semiconductor value chain is made up of many different suppliers for nearly all the steps in the design to fabrication process. That said, there's clearly concentration at several nodes, such as advanced geometry manufacturing, parts of the capital equipment supply chain, and in your case, the air interface design. Where do you see opportunities for innovative startups? Because this is one of the ways that Latvia is sort of attacking this problem, is to use a startup ecosystem approach to participate in the more fragmented part of the value chain.
Mm-hmm. Yeah, very good question, and not surprising, I think, is there are huge opportunities we see for especially startups, right? Because per definition, startups are very, very fast. They are highly innovative. They have to be, otherwise they wouldn't exist. So since this ecosystem, and it's of course, it depends on how do you define the semiconductor ecosystem. But we talked again yesterday, metaverse, right? I mean, it is all linked together. And therefore, startups have huge opportunity to benefit from these emerging technologies for the reason that I mentioned, right? Speed, innovation is in their DNA. Qualcomm does cooperate a lot with startups. So do many other big IT and tech companies, and it goes very much hand in hand, definitely.
Okay. And Raimund's one last one for you, from me. Numerous other countries and regions have begun assembling strategies and financing packages directed at development for various parts of the semiconductor ecosystem, from design to manufacturing. Nearly all the efforts have identified human capital, not financial capital, as the key resource that needs to be managed over the next decades. If you add up the shortage or the calculated shortage of engineers in nearly every market, the numbers are big, right? And everyone's short of talent.
Yep.
You obviously agree with that, but what can you talk about Latvia's specific plans to address that issue on the human capital side, so that you can be successful?
Yes, as and this applies to all the spheres of any of the government strategies, is that together with industry we define lacking skills. So we are in parallel we'll be developing additional skills in skill sets, like new programs, new funding mechanisms for engineer training in the spheres where industry needs, let's say not now, but after 3 years, 4 years. And in parallel, by investing in research programs which are defined by industry, spheres of research which is beneficial for their activities now. By this one, we are developing human capital in the fields which will be needed after, let's say, 8 years. And these are two. So engineering, together with Latvia's largest technical university in the fields of engineering, especially optics and electronics, and research in the field of nanotechnologies, where there is strong scientific background already, and which together with existing industries, they can quite clearly define what would be needs, let's say, in 8-10 years. And these are two fields where advanced skills in research part, which will be developed by doing research, and engineering students, funding students in engineering in semiconductor field and optics, which will be another field where we are building skill set.
Okay. And how do you, when you think about the human capital part of that and the training of engineers and technical professionals, how do you think about the retention of those people here in Latvia? Because I mean, ultimately, I'm assuming that's a goal as well, because otherwise you're just exporting all your intellectual property, if you will. How do you think about that over time?
Yep, it's somehow, it sounds probably simplistic, but it is really simple, because when we discuss about engineering student investments in engineering students, we are discussing what will be salary levels in the local industry, so that not both sides, students and industry, become confused. We just can't afford, in these advanced technologies, we just can't afford salary levels which is below, let's say, Germany.
Right.
It's just impossible. Then this field, so if business doesn't show that they can sustain such levels, then we are not investing. There is no sense, and we will be burning just money. Then we better invest in research and science, and we know that this is another part where in this field, in research and science, we need mostly very interesting and on the edge possibilities for publication. So in science it's a little bit different probably motivations, but that's the basics of this. So that's why we are building on commercial needs first, that we do understand that these people will coming out and they will be working in their field by the salary which they expect to receive globally. So yes, I know that they will be not receiving directly at the first year salary of Germany, for example, in semiconductor industry, but at least that we do understand that if you sum up standard of living with expectation in their career, what is possibilities of growth with salary, they can be compared with Sweden or Germany or Poland, whatever we compare. So this is a basic. So that's why, again, and you're completely right about this question, that top-down strategy doesn't work, because we will be shooting in not seeing where we are actually hitting. So that's why this industry's involvement is so important, that they are actually defining all the route where we are moving, and we are just deciding whether there's a sense for government to co-invest in such opportunity.
Okay. Do we have any questions on the that you've received online?
No, but maybe
Okay.
we have an audience.
We might have one here.
Yes? Wait for a microphone. We have online listeners.
Nitin Dahad with EE Times. You talked about regional strategies for semiconductors. You talked about capping the brain drain after you've trained them. But what is the regional activity? I know you work closely with Estonia, Lithuania. Is there a regional strategy?
Not yet. There is no regional strategy in the sense that it is codified and agreed on. If you look at what is going on, then yes, there is, but it's not communicated between the countries. There is each of countries already for a long time is going a little bit slightly different routes of where we are investing in especially in brains, and in this sense it's clearly there is a good place to in one stage to have this, but it's if you know Baltics from inside, then for us it's the hardest to agree with Lithuanians and Estonians. It's easier to sit down with Germans, France, Sweden, or whatever, because we are close. But this is inevitable. It will happen in one stage when we will, and when the first steps, let's say 2024 most probably will be the year when the first steps will be done at home. Then most probably we'll realize that it's coming together. There is. I can already imagine what technologies can be cooperated in Latvia and Lithuania, and the same applies to the design and IT part with Estonia. So yes, this is really an avoidable route where we will just be forced to go in, but on this stage, no.
Yes, question?
Thank you. A lot of the European strategies that we're seeing at the moment seem to be based on, either resilience or, the lack of capacity today. Is there a risk when the big fabs sort of come online again and there's overcapacity maybe in the market in a few years' time that might diminish investment and continued investment in sort of these regional opportunities? Or do you think that the resilience sort of mentality will sort of outweigh that, and investment will continue even if there is global overcapacity?
I can answer that. So I mean, as we forecast a significantly growing demand in semiconductors in the next 10 years and probably beyond, there's definitely room for additional capacities, also beyond the fact that, rightly though, countries and regions try to reduce their dependency on the one region or the other. So we will, and that has been the same in the past, always see changing demands in the market, right? Very much linked also to overall global economic situation. But overall, the trend is very clearly foreseeable from our perspective, and usually we have a quite good insight into where the market is heading to because of the reasons I described. Yeah.
Yeah, and from our perspective, if I look like from government of Latvia perspective, then it's clear that we don't participate in this frenzy on this time because everybody is thinking about this. It means that don't. For us, we must, and again, cycle shows that most probably in 15 years' time there will be next big problems around this one. Till that moment, we will have to have developed capacities that we can add more than just today's needs to production. It's twofold. It's small countries we can't. There is fields where we are fast, but then there is a fields where we choose too small. It doesn't matter whether you build a fab in I don't know, in Germany, on Finland, France, or in Latvia, it costs the same. So there is no sense, and that's why we don't do this one. But there is huge opportunities. If you imagine that there will be whatever result, whether over capacity of production, or as a result, most cases where there is drop in price as a result, there is much higher adaptability of such technology afterwards. It means that for these opportunities we have to be ready. This is what we are trying to build. That if there will be overcapacities, then we will be designing at that stage our own chips and producing whatever we will want.
Thank you.
I'm going to actually add on to that question if I can. So when you think about to the question that was asked about when the capacity comes back online, don't we have to talk about and differentiate what capacity that is? I mean, at what technology node? I mean, you and I were talking beforehand a little bit about the perception that you have of maybe the market ignoring the more mature technologies and the capacity needs that those are going to have, that we're going to have for those sets of chips going forward, not just for chips at the very, 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 very low geometries. I mean, can you talk a little bit about that?
Yes, sure. So, I mean, as we currently see many regions, many governments trying to incentivize and support allocation of production capacities, what we believe is needed is strong cooperation among countries, among regions, to avoid what you have indicated, right? That we over-invest into certain node sizes, into certain technologies on the one hand, while investment and support for other node sizes is lacking, right? So the efforts that we see in Europe, that we do see in the US, to set up regional production capacities, regional ecosystems, we strongly support and believe it's right. But at the same time, it doesn't mean that Europe nor any other region in the world will be able to build up a self-sufficient, independent semiconductor supply chain, right? Therefore, semiconductor business and the supply chain is way too complex, way too much interlinked, and therefore strong cooperation with all partners globally remains even more important.
Okay.
Great.
Thank you, Dean and the panelists.
Thank you.